Hello guys, today we will derive the world famous equation E is equal to mc square. But before that, we need to understand Einstein's special theory of relativity. Before coming to the theory, let's understand two postulates of relativity as stated by Einstein. First, equivalence of physical laws. The laws of physics are the same in all inertial frames of references. Inertial frame is the one which is not accelerating. That means either velocity is zero or constant. The second postulate is about the constancy of the speed of light. The speed of light in a vacuum is about 3 × 10⁸ meter per second, which is the same in all inertial frames of references, and it's independent of the motion of the source or the receiver. Now let's imagine there is an observer whose velocity is 0 and he is observing a spaceship which is traveling near to the speed of light. He will observe three changes in that spaceship. Well, why this happens? Because as per the second postulate, the speed of light should remain same in all frames of references. To make this happen, the space-time adjusts itself in such a way that it never let us cross the speed of light. That means the speed of light is the cosmic speed limit. Now let's discuss the three changes which occur when we travel near to the speed of light. First, time dilation. As much as we go closer to the speed of light, time gets slower and slower. A clock in the spaceship will run slower than a clock which is at rest. Second, length contraction, which occurs in the direction of the motion as much as we go closer to the speed of light. Third, increase in mass. As much as we go closer to the speed of light, our mass increases. As the momentum is the product of mass and velocity, momentum also increases. Because of the increase in momentum, we need infinite energy to accelerate to get to the speed of light. In short, because of these three changes, we cannot reach to the speed of light. Now let's understand time dilation. Imagine there are two plates A and B, and a light particle, that is photon, is traveling from A to B. Length between A and B is L. As we know, the speed of light is constant c, so the time taken for the photon to reach from A to B will be 2L by c. Now imagine both plate A and B are moving in a constant velocity v. In that case, the time taken for a photon to reach from A to B will be 2d by c, where d is the distance covered by the photon to reach from plate A to B. Here we can see that the distance d is greater than L. So the photon will take more time to cover distance d. But as per the second postulate, the speed of light should remain constant for both frames of references. That is, both moving and steady frames of references will observe the same speed of light. Here d is the hypotenuse of the triangle. So by the Pythagoras formula, we can calculate d. After further calculating and eliminating L and d, we can write this equation in terms of time and velocities. We get this, that t dash, also called as t prime, is a proper time which will be observed by the observer, which is in the moving frame of reference with the constant velocity v. We see that term in denominator is very important in the theory of relativity. We call it as a gamma function. Let's plot the graph for this gamma function. We know that the velocity v is smaller than c and v never reaches c. If we put v is equal to c, then the gamma becomes infinity. So this was about the time dilation. But the same gamma function is used to describe other two remaining relativistic changes, for length contraction and for increase in mass. Here is the real crux of the theory, the increase in mass. We know that the mass affects the momentum. According to Newtonian concept, the momentum is the product of mass and velocity. And we also know that according to the law of conservation of momentum, it remains constant, that is conserved after collisions. But in the theory of relativity, we saw that mass changes in velocity. Now let's see how the change in mass affects the momentum and how the change in momentum affects the energy. Let's take the formula of the relativistic mass. Square the both sides and multiply the bracket. Now let's differentiate the equation. Here mass and velocity both are changing, therefore both are differentiable. This will be the product of differentiation. Here m0 is the rest mass, which is constant, therefore its derivative will be 0. Now let's keep c0 dm on one side and remaining terms on other side. Let's say this is the equation number 1. Now let's talk about the kinetic energy, which is equal to the force into displacement. We know that the force is nothing but rate of change in momentum with respect to time, and momentum is the product of mass and velocity. Let's differentiate them with respect to time. We get this. Put this in the above equation and we get this. Now we can interchange these terms and can rewrite this equation like this, where rate of change in displacement is nothing but velocity. So our equation will be mv dv plus v square dm. Let's say this as a second equation. Now we can see that the right hand sides of both equation 1 and 2 are same. Therefore we can equate left hand sides of both equations. Now let's integrate the both sides, where the limits for m will be m0 to m. So we get k is equal to c square into the bracket m minus m0, which can also be written as k is equal to mc square minus m0 c square. We know that m0 is the rest mass, which is constant, but this m changes with velocity. When velocity is 0, kinetic energy should be 0, but this term m0 c square won't be 0. Thus, it is called as rest mass energy, which is equal to m0 c square. Now, the total energy E will be equal to kinetic energy plus rest mass energy. When we put values for kinetic energy and rest mass energy, m0 c square get cancelled. And finally, we get E is equal to mc square. Thanks for watching, guys. For more such videos, please subscribe our channel.